Welcome to the screencast of 7.5 properties of logarithms.
Woo! Go.
Whoop. All right. So because
My channel.
yeah, subscribe.
Smash the bell.
Remember to hit that like and subscribe. Here we go.
Hey, what's up, guys?
Maddie smokes. You know I'm talking. Okay.
Well, if you want to subscribe, you should be like, yo, what's up, Adam? I know you're watching
Well, that's for 1 subscriber. All right.
this.
So, guys, we did it. We hit 1 subscriber.
Thanks to
There was
you.
that one
There's
guy.
black for one
There's the one guy who was like, "Yeah, I got 1 subscriber," and it was like his grandma, and then she unsubscribed. Yeah.
No.
All right, wonderful. We've talked for 49 seconds. All right, so properties of logarithms.
Yes.
Because logs are exponents, their properties are derived from the properties of exponents. There are 3 properties of exponents. Do you remember the product property? Remember the product property of exponents? So, literally, oh my god, why did it turn on its side? Okay, okay, well, I feel like we should restart the video. Continuing from where it spazzed out. Okay, so let's talk about properties of exponents. So for instance, the power property. Alright, this lag isn't too bad. So if I had x squared to the 4th power, how do I solve this?
Multiply.
Exactly, x to the 2 times 4, which is just x to the 8. Okay. So that is the power. If I have product, so remember, power, you just multiply. Product. So if I have x squared times x to the 7th, this would literally be x to the 2 plus 7, which is x to the 9th power. You add them. So if things are being multiplied, you add them. You add the exponents. Yeah, we're good. Grooving. Okay. Yay for the feedback. All right, and lastly, we're gonna do quotient. All right, so quotient. All right, quotient. If I have x to the 8th over x to the 6th, you subtract x to the 8 minus 6, which is just x squared. Alright, so that's what I mean when I say these properties of logarithms, aka this whole like screencast, the whole lesson, it's just going to be about the properties of logarithms. We just talked about the properties of exponents, the power property, a exponent to an exponent you multiply, the product property, the bases are being multiplied, you add the exponents, and the quotient property, the bases are being divided, so you subtract. Alright, so first thing we're going to talk about is the product property of logarithms. So for all positive numbers, m, n, b, where b, blah, 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 okay, log base b of, there's this number, 2 things being multiplied, m times n. So according to the product property up above, when the bases are being multiplied, you add the exponents. Okay, so we'll split up m and n and we will add them together. All right, so let's examine the logic. Do we have our notes out? All right, just a second. All right, so let's dig a little deeper into this. So on the left side, notice that my base is 2, right? Log base 2. So I could rewrite this as log base 2 of, and rewrite 8 and 4 in terms of 2 to some power. 2 to the 3rd times 2 to the 4th.
Why did you do
Trying to prove that these are the same thing to you. I'm trying to prove that the left side, log base 2 of these 2 things multiplied, will be the same thing as the right side, as if I broke down the inside result and split it into 2.
So you want to put it in terms of the base? Is that what it is?
This is just proving that the left side is equal to the right side.
Yeah.
But when you're actually going through the problems, this is not what it's.
You don't have to put it in terms of the base. Like,
Um,
match the twos.
You'll want to break it up. Just, okay. Do you mind holding your question just for like a minute? Okay. On the right side, I'm going to rewrite log base 2. I'm going to write 8 as 2 to the third power. So I want to prove the left side and the right side are the same thing. Log base 2 of 4 is just 2 squared. So I could take each one of these, for instance, on the left side. So if I write log base 2 of 2 to the third times 2 to the fourth equals y, and I'm writing this, what? Okay. I don't know, you just asked. So I can say 2 to the y is equal to 2 to the third times, oops, is that supposed to be, oh, it's supposed to be the second, I'm sorry. 4 is 2 squared. Yeah. So I see here that y is going to be equal to 3 plus 2, which is 5. So the left side is equal to 5. Let's see if I can get the right side equal to 5. So what I'm trying to do is prove the product property of logarithms to you by using an example. And then after this, we'll just use it as we go on. Max, pay attention. All right. So I'm on the right side. I'll have log base 2 of 2 to the third equals y. I'm just rewriting this in terms of exponential. 2 to the y equals 2 to the third. What's y here equal to? 3. Then I'm also going to write the log base 2 of 2 squared. 2 to the y is equal to 2 squared. So here y is equal to 2. 5 is equal to 5. So I'm proving the product property of logarithms. Alright, so that proves the product property. Now we can go ahead and we can use it. So for example 1, we want to use log base 3 of 2 and log base 3 of 7 to evaluate each of the following. Meaning I want to break this inside part into a series of 2's and 7's. That would be ideal. Alright.
What do you do before you set each of the logarithms to y?
Well, that's how we knew how to solve logarithms. This is what we've previously learned.
Yeah, I know, but like each individual one, so you wouldn't like have the other side just, you didn't do all of the other side equal to y. You did
I did.
log 2 times 2 to the third equals y, and then 2 to the second equals y. Right?
Yeah, because there's that plus sign. Because I have the plus sign, it separates those logs on the right side.
So you solve for each of them individually?
On the right side I had to, because there was a plus sign in between them.
And then what do you do with them when you solve?
Well, I found what the values were. So I came over here and so this whole example right here is just proving, I just wanted to prove this right here. I was trying to prove the product property to you. Okay, so if we go, like doing more examples will help you understand a little better. So here, I want to use the product property. I want to use log base 3 of 2 and log base 3 of 7. Meaning, I could rewrite log base 3 of 14 as log base 3 of 2 times 7. And then since we know the product property of logarithms, aka if I'm taking log of a product, I can separate it out into addition. So I'll literally have log base 3 of 2 plus log base 3 of 7. So this is, I'm trying to think of another way to say it too, like this is the rule for logarithms. It comes from the fact that logarithms, the answer to a logarithm is a product, is an exponent. The answer to a logarithm is an exponent.
So it's like you're distributing the 3 out.
Yeah. Yep. So we know log base 3 of 2 is 0.6310 because that was in the directions. I know log base 3 of 7 is 1.7712. So if I just add these together, I'll have my solution. 2.4022.
Because that's what they equal.
So when you have two things being multiplied right here, you can separate them out by adding log base of each one of them. Because that's the rule that's up here. So you're taking log of a product. Maybe you don't know exactly what the answer would be if you had it that way, but if you split it up, so you split the n and the m, since they're being multiplied, you can split them and then add the logs together. So this is going to take some practice going through and like using properties of logarithms. All right, so I have log base 3 of 63. So this one, I just add them together. Let's pop it up.
And set it equal to log 2.
So this is equal to it.
Okay. So like what you showed is like what we do, except we don't have to set it equal to it.
This is what it is equal. It is equal to that though.
Yeah, I understand.
Oh, yeah, so at the end I don't necessarily have to write log base 3 of 14 equals 2.4022. That's extra, I don't really care. I can see your work. Is this what you're talking about, setting it equal?
Yeah.
I mean, you could, if that helps you, but it's fine. Technically, that's what it is. Alright, so on the right side, log base 3 of 63. So I could rewrite this as log base 3 of 9 times 7. And since I have a product, I can separate the 9 and 7 out. What I mean by that is I can take log of each of them separately and add the logs together. Do we know what log base 3 of 9 is? It's 2. And the whole reason for that is, let's see, log base 3 of 9. So 3 to the y equals 9. So 9 to what power equals, 3 to what power equals 9? 2. That's why it's 2. And then, let's see, I know log base 3 of 7 because I gave that to you, 1.7712. So you add these together, we get a total of 3.7712.
Is the answer, why is the answer no?
What do you mean?
Why is the answer not the same as it is in the log?
Because it's a different number.
63.
Taking log 63 instead of log 14.
But we end up with 2 and
Here I had 9 and 7. On the left side I had 2 and 7. They're different numbers.
you like how
Alright, so quotient property. Alright, so the quotient property, so remember how we did quotients with exponents?
Yes, we subtracted that.
So it's almost like we're going backwards. So if I'm dividing two bases, I'll be subtracting the exponents. Here, the thing I'm taking a log of, if I'm dividing, the thing I'm trying to take the log of, if it's dividing, I could split it up by subtracting log of the top minus log of the bottom. Same. Okay. So that's what this is saying. Literally log of the top minus log of the bottom when you have something in a fraction. Alright, so we're going to use log base 2 of 3 and log base 2 of 7 to evaluate each of the following. Okay, so right now I have log base 2 of 7/3.
So subtract the top from the bottom.
Exactly, so I take log of the top minus log of the bottom.
2.8 plus 7 minus 1.
Okay. Ready for the next one? Alright. Next one's gonna be a little more difficult. I'm just prepping you for it. Alright, Chloe, sit up. Leona, sit up. Jonah,
Yeah.
sit up. This is sleeping nonsense. Are you kidding me?
I wasn't sleeping.
Uh-huh. I was just had my eyes closed while I
do this
watched
one right
you.
now. This is Brian right now. Let's go.
Okay. What?
Ready? We're gonna do this one.
You want to fight?
Alright, so I have log base 2 of 36. So ideally, I want to find out what this is. So I could use...
Minus log base 6 and 6.
Hmm?
6 and 6.
No, 6 and 6 multiply.
6 and 6 multiply, I could do that.
You can do 36 minus 1. Yeah.
36
Minus 1.
minus 1?
Because it's the top of the bottom.
Oh, 36 over 1. Well, that doesn't really help me. Log of 36 minus log of 1. I don't know what log of 1 is. I want it in terms of log base 2 of 3 and log base 2 of 7. So I could use 3.
Oh, you could use
You could
3
do
and
3 times 2.
or-
You could just multiply 1.5 by 2.
7 does it, so that's why I'm going to be using the 3. So log base 2 of, well, I could do 3 times 12. So multiplying out. So if you are multiplying, you take the first thing, log of the first plus log of the second. Since I'm multiplying, I'll do log of the first plus log of the second.
Log 2 is 2.
Log base 2 of 3 plus log base 2 of 12. Okay, well, I know log base 2 of 3. I already know that, so this part's good. What's your question, Zach?
So it really matters.
No. But it's just good being in the habit because the subtraction does matter. The quotient does. So I have a problem.
No, we can solve it.
Problem with this guy.
Well, you know, you have your calculator.
We need to solve this.
Well, 12.
So I'm gonna copy what I wrote for the first line for the first thing. But then this, I'm gonna make log base 2 of
3 times 4.
do 2 times 6.
Why did you do 6? If you have 3, then you can do.
3 times 4?
Yeah, because you already know what 3 is.
Yep, okay. 3 times 4.
Would you also do logarithms?
No. We're practicing with properties of logarithms.
So we're like, okay.
So we are practicing using the properties of logarithms. That's why I gave you log base 2 of 3, what it's equal to, and log base 2 of 7.
And now,
It's kind of like if I was trying to teach you how to drive, and you're like, but I have my chauffeur. Like, no, that defeats the purpose. That's not what I'm trying to teach you. Throw it back. Yep. I don't think he watches these. Alright, so if I'm multiplying, you take log of the first plus log of the second. Okay, so I'm going to rewrite. So that way I don't lose my first term, but then I have log base 2 of 3 plus log base 2 of 4. Am I good? Like, can I solve this?
no.
Is log base 2 of 4, is that something we could solve? Is 2, like, like right here? Log base 2 of 4, I'll rewrite in terms of exponential. 2 to the y is equal to 4. So what is this equal? 2. Because I'm looking for the exponent. Log base 3 of 2.
It doesn't log 2 really like cancel out. It's just 2.
No, you add it twice. Alright, so we got log base 2 of 3. Both of those were literally in the example directions. They gave us those numbers. Log base 2 of 4. Right, we rewrote it in terms of an exponential. 2 to what power equals 4? Oh, 2. Okay, so I'm solving for the exponent when I do a log. Alright, ready for the next one? It's just going to take practice, and like you need to practice doing properties of logarithms. Log base 2 of 0.75. Ooh.
We can make that a fraction.
Make it a fraction. Okay, so what's this equal to?
3/4.
Good. So this is equal to log base 2 of 3 divided by 4. Oh, wait, I have a quotient. So I will take log of the top minus log of the bottom. Log base 2 of 3, which is the top, minus log base 2 of 4, which is the bottom. Do we know what log base 2 of 4 is?
Yes.
So let's think what that means. Okay, so log base 2 of 4 equals y. So I can rewrite this. 2 to the y equals 4. So that way I know the exponent's 2. Okay, so we were given log base 2 of 3. That's 1.585.
Minus 2 is negative 0.
Perfect.
Is it high time?
No, not yet, not yet.
Or is it back? Yeah, no, I see that.
So this is the first page.
Oh, there's a third page. Oh,
Yep, there is. There is.
this is a long lesson. Long lesson.
You're a long
I
listener.
think it makes it to the 2 other short lessons. I know you are, but what am I?
Mm.
What is that?
Power property of logarithms. So I'll give you a hint. Remember how we talked about 3 rules at the beginning for exponents? We went through the multiplication. We went through the division. Now we're going to go through the power. Yeah, we have when the bases are multiplied and the bases are divided. Now when you have a power to a power. All right, power properties of logarithms. So literally, if you're taking log of something with a power. So I'll give you a quick example. Log base 2 of 16. I could rewrite this as log base 2 of 2 to the 4th. So what we do is we take the exponent and I bring it out top, bring it in the front. So I'm going to be multiplying by it. So I can bring this 4, oops. So I can bring this 4 out front. Meaning I now have 4 times log base 2 of 2. What's log base 2 of 2? Went through this?
4.
Is 1. Log base 2 of 2 is 1. Went through this multiple times. Log base 2 of 2. Alright, if I set this 2 to the y equals 2, that means y is just 1. So what's 4 times 1?
4.
4. So that's cool. So 4 times 1 is just 4. That's the answer. If I came over on the left side, I could evaluate this logarithm. So I'm proving to you that this works. Log base 2 of 16 equals y. 2 to the y equals 16, and that also is 4. The exponent's 4 there. Yes?
So how are you taking away 4 and you like to?
So that's the power property of logarithms. Literally, if you have an exponent, you're taking log of something with an exponent, you take the exponent and bring it in front.
You don't have 2 to the second one, do you? It's just log base 2, 2.
Right.
Okay.
Yep. So we're trying to let's
now it's
what's wrong?
for
Okay.
so are you saying them equal to each other now? Like log 2
So I'd
of
prove to
2
you-
4 equals 4 log 2
Am I setting what equal?
Or you just solve them for
Okay,
the
so
right side then?
I'm proving that So log base 2 of 16, we could have just came down here and solved for it, and we see it's 4, the answer is 4. So instead, I was like, let me show you that this is true, so I rewrote log base 2 of 16 as log base 2 of 2 to the 4th. And since I have an exponent here, I'll bring it to the front, so now I have 4 times log base 2 of 2. I know log base 2 of 2 is 1, so I'm proving that 2 here by writing an exponential form. I'm like, okay, I see that this whole thing can be replaced by 1, so 4 times 1 is 4. So showing you a problem where you already know the answer, showing you a way to do it proves that like this way works. That way when you have a problem that you don't know how to solve without this, you know it will work. Yep. Cool. All right, so example 3a, solve each of the following equations. So I have log base 5 of m equals 1/3 log base 5 of 125. So first thing I want to do is I notice I'm multiplying. I have this right side, and it's being multiplied by a third. What should I do with this third? Yeah, I'm going to raise 125 to the power of 1/3. Nope. Literally, it's to the third. No, because up here, if you have a power, you just move the power and multiply it on the front. So, if I wanted to take that power and move it back up here, I'm just moving the number. And the only reason we can do this is because it's a logarithm. Alright, so I have log base 5 of m equals log base 5 of 125 to the third power. Now we're going to use our previous knowledge, like what we've already learned. If I have matching bases, guess what? Both sides have log 5. What can I do at the inside? What can I do here? Yeah, I can just set the insides equal each other. So m equals the cube root of 125. Because remember, having something to the third power is the same thing as the third root.
It's 5.
So what times itself 3 times is 5. M equals 5. Cool.
I know it's going to get harder.
Yep. You said someone was saying?
What?
You said someone was saying, or you just know?
I said I feel like it'll get harder.
Yeah. All right, let's go through B. All right, so. Yep, so the first thing I'm going to do is I'm going to move this 2 back up into its exponent. So I have log base 3 of y squared plus log base 3 of 0.1 equals log base 3 of 5 plus log base 3 of 2. Alright, so one step at a time, right? The first thing I did, alright, so that was the power. That was the power property. Now, what property do I want to use for the second line?
Can you move log base 3 of 0.1 to the other side?
Can I do what?
You move the log base 3 of 0.1 to the other side, so you have y.
Not quite. Not quite. So I'm going to use the product property. Do you remember what the product was? Yes. So before, I had 2 things being multiplied. I separated them by adding, like the first number, log of the first number plus log of the second. Here, I have log of a number plus log of a number. So I'm going to take these and combine them. So this will be the same thing as log base 3 of y squared times 0.1. I wrote that really funny. Multiplied by 0.1. And that will equal log base 3 of 5 times 2. Because earlier we went from the product to the addition, right? We went from 5 times 2, log base 3 of 5 times 2 to log base 3 of 5 plus log base of 2, right? I split them before, now I'm bringing them back. So before we were expanding, now we are condensing. We're making it smaller, we're trying to simplify. All right, so let me actually do the multiplication out. So I have log base 3 of 0.1 y squared equals log base 3 of 10. Now what?
Now you can set it.
Exactly. Because we have the same bases on both sides, I can set what I'm taking log of equal each other. Because both sides only have one log and it's the same base, I can take whatever I'm taking the log of and set those equal to each other. So I have 0.1 y squared equals 10. So first step I want to do, divide by 0.1. Y squared equals 100. If I square root both sides, y equals 10. Yeah, so that was a little bit more in-depth problem, but it's fine. We just need to practice condensing and expanding. We're doing okay. All right, let's try part C. Do you guys need time to write this down? Yeah? Okay. Okay.
I'm going to start with I asked for
That's fine. Yeah, they do that to me too sometimes. Ugh. All right, so let's go to the next part. All right. So, here's what I got. Do you have any ideas on
Yes.
what I could do? Yes. Hold on. Let's make sure we're all writing notes, paying attention, sitting up, being wide awake, alert, enthusiastic. Did you ever do that at camp? Wide awake, alert, enthusiastic?
That may be an element.
I thought it was I'm alert, I'm awake from the light.
Yeah, whatever.
At the end.
A wide awake, alert,
What?
enthusiastic. I'm alive, alert, whatever. Just sit up and don't be sleeps. Okay, no sleeping.
My turn.
All right.
So we know that, so in this case, we have two P's and two M's. But eventually, they're all supposed to equal log 7M. So what I would do is I would solve for both of those, and then I would
Yeah, so the first thing I would do is move whatever coefficients I have up to being the exponents.
exactly.
Okay.
So
Let's rewrite that.
you would get 4 for the first one.
I'm showing every step. So before I move on, I could simplify both of these. For instance, 64 to the 1/3 power, 121 to the 1/3 power. So let's rewrite this. Log base 7 of m equals log base 7. All right, so the cube root of 64. What times itself 3 times is 64? 4. Okay. 4 times 4 is 16. 16 times 4 is 64. Okay, so that's 4 multiplied by itself 3 times. Plus log base 7. So remember, logs are just talking about the exponents. But let's solve the highlight portion. 121 to the half power. What that means is square root. If you have the half power, it means the second root. What is the square root of 121? 11. Okay, let's simplify this a little bit. Now,
Now, you know, by the product one, or the addition one, log 7 base 7 to 4 plus log 6 base 7 of 11 should equal log base 7 of n. So I would say that n is 15. I think 1/4.
since I have the same, all right, so I did the product, which means if you have log, two things added together, right? One log added to another and they have the same base, you could literally take the inside portion, just multiply them together. So 4 times 11 is 44. And now that I have the same base here, I can set the insides equal, so m equals 44. Alright, let's take a second. How are we feeling so far? Whoop, whoop, tired? Okay, cool. Alright, solving law of arithmetic equations using product, quotient, and power rules. Yeah, so we're trying to solve for what the value of x would be. So this is just the same thing we've been doing. Yep. Alright, take it away.
Okay, so if it's so you put the 4 as an exponent by the x, so become log base 2x to the 4. What do you divide it though?
Divide what?
Like it's minus, so wouldn't it be minus?
Exactly.
Divide by
Yep,
squared.
so let's see, we used power. Now we're going to use quotient.
So then it's log base 2x to the 4 divided by log base 2 to the 5th.
Mm-mm.
Just
You get rid of the log. Like you by combining the insides, it's log base 2 of this entire thing
oh, okay.
equals log base 2 of 125.
Right. Which is 5 times 5 times 5.
Well, let's see. Same base. I can set x to the 4th over 5 to 125. Multiply by 5 on both sides. X to the 4th is 625. How do I get rid of a 4th power?
Square root. Yeah.
It's to yeah, I put it to the 1/4. Put it each side to the 1/4 power. Not negative 1/4, just 1/4. Because on the right side, I'm left with x. What times itself 4 times is 625?
45.
5. It's 5 times 5 is 25. 5 times 1 is 5 times 5 is 25. 5 times that is 125. 5 times that is 625. So that's 4 times multiplied together. Yes. Yeah. Let's do it.
So, move the 2 to the power of negative x squared to the log 7x squared. And then that would equal log 7 times 2701. Okay.
Yeah.
And could you set it equal now? Please?
Do what?
You can set it equal now?
Yeah.
Okay. So x squared equals 7. And
Do we know what that number is?
so 2,187.
Let's go. Cool. Awesome. Okay, and so far this is making sense, right? So far all the values we've found to plug in our logarithms are positive, which is good because we can't take log of a negative number. Let's try C. Alright, oops, there should be parentheses around this. Alright, so, alright.
So with the product property of logarithms, x times x plus 5.
So log base 6 of x times x plus 5.
Should equal 2. So x will get x squared plus 5x.
Okay, so log base 6 of x squared plus 5x equals 2.
That 2 doesn't have the same log base.
Exactly, so how can I solve?
So you can make it have the log, yeah, exactly.
So what am I doing here?
So you're doing just log.
Converting to exponential form.
So it's 6,
Okay.
36. Or I guess you could cross that.
No. Subtract 36 from both sides. And then I'm going to have to factor.
So x by 36.
What are the factors of 36? We have 36 and 1,
Oh,
18 and 2.
It's 6 and negative 4.
6 and what?
No, 6
No,
times
wait.
negative 1.
No.
It's 4. It's 4.
9 and 4.
9 and 4. Okay, which one's positive and which one's negative?
Negative
9 is positive.
Yeah, because if I add negative 9, or negative 4 and 9, I get 5. Multiply them, I get negative 36. Okay. So, x minus 4 times x plus 9. And I have to actually find what the x values would be. But the thing is, if I plug in, right, to check what happens right here. If I plug in a negative 9, I'm taking log base 6 of negative number, and I can't do that.
So it has to be.
So the only answer I have is x equals 4. Okay. And then this is the last example. It's relatively short, but it's literally, who's in chemistry right now? Who took chemistry in the last year, or is in it? Okay, so it's pretty much, that's everyone. That's everyone. All right. So we know what pH is. pH is an important tool in chemistry. pH is on a log scale. What's that face? Are you okay?
What?
Oh, okay. No, I wasn't looking at you. pH, important tool in chemistry. A couple things to remember. 10 to the 4th. What?
I'm mixing two of my worst subjects.
Best subjects. Hashtag best. Okay. It's fine. It's fine.
You're crossing
I
the
didn't say I don't like them, I
streams.
just said that's like my worst grades.
But like, I don't understand. This is a little rant. I'm trying not to, but I don't understand why like things are so compartmentalized. Because literally, you use math in lots of other classes, and you use English in lots of other classes. Like for instance, in this class, you guys have trouble reading directions. Yeah, and that's English. Literally understanding the content of the words and wanting to know, okay, what is it saying to me? Science is a good example because you use English to read the directions. You use math because math is the language to solve.
I don't see anyone using music theory in any other class, so why do we need to use chem in this class?
Why do you use what?
Music theory on any other
I do.
class.
I use it a lot actually. Harmonics, different resonant frequencies and frequencies. Yeah,
So that's wild, actually.
yeah. We can talk about this. You are talking to the wrong person, Matt. I have come back. Come at me. I'm ready. All right. 10 to the 4th power. Guess what? It's 1 followed by 4 zeros. Woo! 10 to the 4th is just how many zeros there are. Yeah, poor Matt. He's a really good saxophone player.
Yeah, I bet.
Oh, I sat in the junior meeting yesterday for 20 minutes watching videos, so that was fun. All right, 10 to the 5th is literally 1 followed by 5 zeros. 100,000. Okay. So pH is like how much acid it has. Literally, like how basic or acidic it is, and it also like secretly is talking about like the bonds of the atoms, if they're more negative or positive. Depends how volatile it is. Anyway, pH is equal to negative log base 10 of H plus, so that's just hydrogen. So another way we could write it is here. And the whole reason is because this negative 1, I could put this whole part to negative 1, which means it moves to the bottom. Okay, kind of cool. Hey, interesting. It's like you know math now. All right. What is the pH of a solution whose hydrogen ion concentration is 6.3 times 10 to negative 3 moles per liter? Okay. So this right here is your hydrogen ion. This is your hydrogen ion. And we know pH is literally negative log base 10 of, here, plugging that in, 6.3 times 10 to negative 3. So if you plug that into your calculator, what do you get? Yeah, it's wild. Alright. Oof. That's it for this problem. Its pH is 2.2. This is how you calculate the pH. So what's the pH of water? 7, because it's neutral. Is this basic or acidic?
Is the less pH is more.
Yeah.
This is crazy pH. This is rough. This is, if you touch your skin, goodbye skin. It's no longer there. Yeah, no bueno. Okay. Example 6. What is the hydrogen ion concentration of a solution whose pH is 8.5? So what are we looking for? We're looking for that H plus. I know pH is equal to negative log base 10 of H plus, so I'm trying to solve for H plus. So the pH is 8.5. 0.5.
You do the little arrows.
Yep. Doing little arrows. 10. Let's see. So let me move the negative to the other side before I do that. My bad. So I have negative 8.5 equals log base 10 of H plus. Now I can move it over. So I have 10 to negative 8.5 is equal to the H plus concentration, the hydrogen ion concentration. So I see that concentration is 3.16 times 10 to negative 9. So this is of a basic solution. All right, cool. So this is the homework. We have like, a little bit of time. I'll go get some